Hi, and welcome back to Allen High School's discussion of bonding at the pre-AP 10th grade honors level. Now, this is bonding that we're talking about with ions and electrons and atoms is very difficult to visualize. And so we need to come up with some sort of model that will help us visualize it, or a representation of what we're looking at. And the Lewis dot is one of those. Now, when we're talking about Lewis dot structures, it involves the valence or outer S and P electrons, because the outer ones are the most likely to become involved in bonding. The core ones aren't likely to be attracted to another nucleus, but the valence ones might get close enough to be attracted to another nucleus. Now, the valence electrons are useful for predicting the ionic charge. Now, ionic charge is a subset of a bigger concept called oxidation number. So for now, we're going to treat them as equivalent. They're not really. Oxidation number is a much bigger concept than ionic charge is. And so you could write oxidation number into that blank if you want. Okay? Now, for group one are metals. Now, I mentioned earlier that metals are losers, and they become +1 when they lose 1 electron. Now, because we're gaining and losing negatives, this can become a little tricky for some people. So if you will envision a number line, and that's 0 on the number line, what you want to ask yourself is it becoming more negative? Because if it's becoming more negative, it's gaining those negatives. And instead of asking if it's becoming more positive, ask yourself if it's becoming less negative. Less negative means a loss. So the more positive it is, right, the less negative it is. So if it's less negative, you lose electrons. Okay, group 2 metals have 2 valence electrons. Their configuration ends in S2. So they have 2 valence electrons. They become +2. They're becoming less negative, so they lost 2 electrons. Group 13, we're not going to talk about the transitions. Valence electrons aren't helpful so much for them. So they have 3 valence electrons. They lose those 3 valence electrons and become +3. Group 14 has 2 possibilities, and I'm going to talk about the metals here. They end in S2P2, so they have 4 valence electrons. If they're nonmetals, they can gain 4. And the goal here is to have 8 electrons. What this is called is the octet rule, and the goal is to gain or lose until you have 8 valence or outer electrons, and that's called the octet rule, or 8 outer S and P. That's the octet rule. Okay? Now, metals, because in group 14 there's both, the group 14 metals can either lose their P electrons. If they lost their P electrons, they become +2. If they lose their S and P electrons, they become +4. Group 15 is similar. They end in S2P3. So if they gained 3 electrons, they can become -3. The nonmetals will do that. The metals can lose either 3 to become +3 or both to become +5. Group 16, we're talking about primarily nonmetals. Well, we are talking about nonmetals. They gain electrons to get 8. And I don't know if you've noticed, that makes them just like the nearest noble gas. And that's also gain electrons. And so the octet is to have S2P6 is the goal. And when they do that, they're just like those non-reactive noble gases, and that's the octet rule. Now, this is, something I want to emphasize for you, because students will often miss this, is if it's an element all by itself, you memorize these oxidation numbers, but if it's an element, a pure substance all by itself, its oxidation number is 0. If it's pure, it has nothing to give electrons to, nor take electrons from. So if I have a hunk of sodium, solid sodium metal, it's got an oxidation number of 0. If I put that in my mouth, it's going to explode. But if I put table salt, sodium ion, in my mouth, it won't. We take in sodium ion all the time. So these are very, very, very different. And sodium, pure sodium metal, is 0. Sodium ion is +1. All right, and the oxidation number for the noble gases is 0. They don't like to form ions. They don't like to react. Now, there are a few other metals, and we're going to summarize this on a periodic table. There's a few metals that you do have to learn. Always take the same oxidation number. And I like to define them by a staircase. So if you'll look at your periodic table and you find silver, there's one step that's +1. 0 if it's a pure substance, if it's pure silver, +1 in a compound. Notice there's 2 steps that are +2. 0 when they're pure, +2 always in compounds. And then there's 3 steps in this staircase that are either 0 when pure or +3 as an ion. Now, chances of you seeing indium are not great, but the beauty of this is it gives you something to visualize. If you can visualize, there's less to memorize. So I think that really helps. Some students and I were talking about it and came up with that over at Collin College, and I think it's really, really helpful. So let's summarize it on this periodic table. Group 1 metals are always +1. Now, the reason we put hydrogen over here is hydrogen is typically +1. Not always, but hydrogen is typically +1. All right, group 2 metals are always +2. The transition metals, most of them vary. Now, not all of them, but we're going to lie to you a little bit and say that the only ones that don't vary are the ones that I defined that staircase for. So here's your staircase. So I'll ask you often, is it group 1, group 2, or part of the staircase? And you'll have to be able to identify whether it is or isn't. So step 1 of the staircase is +1. It starts with silver. Step 2 is +2. There's 2 of them at +2. And then there's 3 of them at +3. So you have to know for these metals, I'll ask you, is it group 1, group 2, or part of the staircase? And that's what I want you to be able to visualize on the periodic table. Now for the non-metal, or let's do these other metals here. Okay, these metals in here, this group here can either be +2 or +4. And these here, same for the ones below. And this one, and really the metals above. And this is +3 or +5. All right, and if you can envision it on the periodic table, it will help you. So +3, 1, 2, 3, +5, it loses 1, 2, 3, and then over here is 4, 5. All right, for this group here, +2, it loses 1, 2, +4, it loses 1, 2, 3, 4. Again, if you can visualize it, you don't have to memorize it. If you're having trouble visualizing it, then you will have to do some memorization. Let's deal with the nonmetals now. Now, unlike these that start at +1 and go in this direction, this starts at 0 because those are your noble gases. They're 0. Then it goes -1, -2, and then -3, and then -4 when they're forming anions. That's their anion charge. Okay? Well, so sorry, you guys. I don't know why my Mimeo does this every once in a while. Maybe it's me. Too much coffee. Ha! Wait a minute, you can't have too much coffee. How silly can that be? All right, so those are the charges. You want to, I'll be giving you periodic tables on quizzes and tests, so you can kind of draw this on if you would like to, okay? I think a lot of people like to do a little bit of a brain dump when they take their quizzes with a periodic table, all right? So until we have time to work on this in class, this is, of course, I don't know, hopefully not just your best chem teacher, but quickly becoming your beloved chem teacher. See y'all in class.